The universe is 13.8 billion years old. It contains 2 trillion galaxies. Each galaxy holds hundreds of billions of stars. The math says we should have heard something by now. A signal, a transmission, a single unambiguous sign that we are not alone. We have been listening for over 60 years, pointed our most sophisticated instruments at the sky, and scanned billions of frequencies. The answer we received is silence. Not a little silence. Complete, absolute, unbroken silence. And that silence is one of the most disturbing scientific facts in existence. Because it isn't what the math predicted. It's the opposite. And some of the explanations for why we're alone are far more unsettling than simply not finding anyone. In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos when he asked a question so simple it seemed almost naive. Where is everybody? He wasn't being casual. He'd done the math. A civilization with even a modest head start on us, a few million years, should have had more than enough time to colonize the entire Milky Way, even traveling at a fraction of light speed. It should have happened, many times over. And yet, nothing. This is the Fermi Paradox. 75 years later, we still don't have a satisfying answer. What we have is a collection of possible explanations. And when you line them up, you realize the problem isn't just scientific. It's existential. Every serious solution says something disturbing about the universe, about intelligence itself, or about us. We haven't found anyone because we haven't looked hard enough. Space is incomprehensibly large. Our signals have only traveled roughly 100 light years, a microscopic bubble in a galaxy 100,000 light years wide. It's reasonable, but the silence goes deeper than distance. The Breakthrough Listen initiative surveyed 1 million nearby stars and 100 galaxies. Found nothing. Meanwhile, Kepler confirmed over 4,000 exoplanets, and statistical projections suggest tens of billions of Earth-sized planets sit in habitable zones within the Milky Way alone. The ingredients for life are everywhere. The optimistic explanation gets harder to defend the more precisely we can actually look. So then you reach the second category, and this is where the tone shifts. Maybe life itself is rare. Not civilizations, life. Despite how common the ingredients appear, maybe the emergence of life from chemistry is a fluke of staggering improbability. The rare Earth hypothesis argues that Earth isn't typical, it's extraordinary. Precise galactic position, stabilizing moon, Jupiter-absorbing asteroids, plate tectonics regulating temperature. Strip any one factor, and complex life may never arise. But here's the complication. Microbial life on Earth appeared remarkably fast, within a few 100 million years of the planet cooling. That speed suggests simple life might not be difficult at all, which forces the harder question. If life starts easily, why aren't there civilizations? Earth has hosted life for 3.8 billion years. For most of that time, it stayed microbial. The emergence of complex cells, nervous systems, intelligence, all of it happened recently, and all of it could have failed at dozens of points. A different asteroid, a slightly different atmosphere, a mass extinction slightly more severe. And that's before civilization. Having a brain doesn't guarantee one. The development of language, mathematics, science, industrial capacity, all compressed into a brief window. It's not obvious that intelligence reliably produces technology. It may be a highly improbable convergence of cognitive traits, social structure, and environment that rarely repeats. Every one of these bottlenecks is called a filter, and they exist on both sides of us in time. This is where the conversation stops being abstract. Physicist Robin Hanson identified what he called the Great Filter, somewhere along the path from dead matter to galaxy-spanning civilization. There's at least one step so improbable that almost nothing gets through. The structure of the problem demands it exists. The math says civilizations should be everywhere. They aren't. Something is stopping them. The question isn't whether the filter exists. It's where the filter is relative to us. If it's behind us, the emergence of life, the development of complex cells, the rise of intelligence, then we are the rare survivors. We got through. We may have a future. But if the great filter is ahead of us, it means almost every civilization that reaches our level gets annihilated before it can expand. And we are approaching it right now. These are not equivalent possibilities. The candidates for a filter ahead of us aren't abstract. Nuclear war, engineered pandemics, nanotechnology that escapes control, climate collapse, artificial intelligence that goes catastrophically wrong. Researchers at Oxford's Future of Humanity Institute and Cambridge's Center for the Study of Existential Risk have argued seriously that technological civilizations may systematically generate tools of self-destruction faster than they generate the wisdom to handle them. The logic closes neatly. It explains the silence perfectly. If even a small fraction of civilizations survive their own technology, the galaxy looks exactly as it does. Empty. Carl Sagan believed the key variable in estimating intelligent civilizations was how long they survive after developing technology. If the average answer is a few hundred years, the sky should be exactly this quiet. But there are darker possibilities. The dark forest hypothesis applies game theory to interstellar contact, and the reasoning, once you follow it, is difficult to escape. Start with two premises that are almost certainly true. Resources in the universe are finite, and you can never fully verify another civilization's intentions. You cannot know if they are peaceful. You cannot know if they will stay peaceful. You cannot know how fast they are growing or what they will want in 1,000 years when they have capabilities you cannot predict. Given enough time and enough civilizations, even a small probability of threat compounds into an overwhelming one. The rational response to detecting intelligent life under these conditions may not be communication. It may be elimination, quietly, before they become capable of defending themselves or striking first. The civilization that hesitates hands the advantage to the one that doesn't. This logic has a corollary. Survival requires silence. You don't broadcast. You don't respond. You hide and you listen, and if you detect someone who isn't hiding, someone naive enough to announce their existence, you act, not out of malice, out of the same cold arithmetic that any sufficiently advanced strategist would eventually reach. This isn't science fiction framing. It is the structure of certain well-understood problems in competitive dynamics, applied to the largest possible scale. And it implies something that is uncomfortable to sit with. Broadcasting our location for over a century may have been a mistake. Stephen Hawking said this explicitly, publicly, more than once. The silence of the universe on this reading isn't emptiness. It's discipline, and we have been very loud. Then there's the possibility that changes the question entirely. What if civilizations don't go silent because they die, but because they evolve past us? The transcension hypothesis argues that advanced civilizations don't expand outward into space. They expand inward, into computation, simulation, and miniaturized complexity. The reasoning is that inner space offers greater returns than outer space. More information processing capacity per unit of energy, more density of experience, more control. A sufficiently advanced civilization doesn't need a galaxy. It needs better architecture. On this account, the endpoint of technological development isn't a civilization that spans star systems. It's one that has compressed itself into something extraordinarily dense and extraordinarily quiet, operating at scales and on substrates no radio telescope was built to detect. They don't colonize. They contract, and they disappear from the electromagnetic spectrum not because they were destroyed, but because they outgrew it. The silence, then, isn't death. It's a different kind of departure, but it carries its own unsettling implication. By the time any civilization is advanced enough to communicate with us, they have already moved past the phase where they would want to. The gap between us and them isn't distance. It's development. We are waiting for a reply from civilizations that graduated out of our frequency range before we knew how to listen. And they have no more reason to reach back than a city has to correspond with the microbes in its soil. Not hostile, not indifferent exactly, just operating at a remove we cannot bridge from this end. And then the hypothesis that requires the most effort to sit with. We are alone, not by accident, As a feature, some cosmologists, drawing on fine-tuned universe arguments and the full weight of the silence, conclude that the probability of any other technological civilization existing within the observable universe is genuinely close to zero. Not impossible, singular. We are not hidden among a crowd. We may be the first, or the only. If that's true, everything that matters about the future of intelligence runs through us. Every decision about our survival carries weight, extending billions of years forward. We are not a footnote in a crowded cosmic story. We may be the entire story. Here is what we actually know. The universe is old enough, large enough, and chemically rich enough to have produced thousands of civilizations by now, if intelligence follows naturally from chemistry. Earth-like planets are common. Organic molecules exist in interstellar clouds, in meteorites, on comets. Life appeared on this planet fast, and none of our instruments have returned a single confirmed intelligent signal despite decades of accelerating search. The James Webb Space Telescope is now scanning exoplanet atmospheres for biosignatures. Technosignature research is expanding. Within decades, we will either begin detecting traces of life elsewhere, or the silence will deepen in ways that force us to confront which filter is real. The silence is not passive absence. It is pressure. It is the universe waiting for us to understand what it's telling us. Somewhere in the answer to Fermi's question, "Where is everybody?" is also the answer to what we should be asking about ourselves. What kind of civilization do we become, and does that choice determine whether the silence, billions of years from now, finally ends?